All right, guys, part of your assignment is going to be to do pages 7 through 14. Actually, take that back, 15. This is a lab. Now, it requires that you have poker chips or something that you can mark either red, blue, or black. Now, I realize that you guys probably don't have that at home. So what I did is I chose to use Play-Doh. I just took my daughter's Play-Doh, rolled it up. You can do this with paper. You can do it with pretty much anything, beans, as long as you have 3 different colors. You decide the key. I chose to stick with this key, red, black, and blue. We didn't have black, so I chose brown so that I could follow the instructions. So what I'm gonna do is I'm gonna kind of walk you through how to do this. All right, so I'm gonna start with number 4. And I did this on my whiteboard so that you guys could see it better. You can do this on your sheet of paper. It does not have to be this scale. It is completely up to you. So we're gonna just follow the instructions. It says make a model of 1 atom of carbon, place 6 protons and 6 neutrons in the nucleus, okay? Now it says cup. I'm saying we can do this on paper since we're not at school. So I'm gonna come over here and I'm gonna get 6 of my nice little red protons. And I'm gonna get 6 of my neutrons. 1, 2, 3, 4, 5, and 6. Okay? Now, let me put this in my nucleus here. So there's my nucleus. Now it says we're gonna use our blue chips. We're gonna use our electrons in the inner electron level, 4 electrons in the outer electron level. So we know if we look at our periodic table, okay, that carbon should have 6 electrons, because remember, the number of protons is equal to the number of electrons. So we have 6 protons, we have 6 electrons. Now, if we remember from chemistry, what we're gonna do is we're gonna start by filling our first shell. Our first shell, we're gonna put 2 electrons, and now it's full. So now we're gonna go to the next ring. So we have 2, there's 3, 4, 5, and you know what? I'll do them like this. 5, 6. Now, this outer ring is not full. That means it's wanting something else. But for right now, we're just building the structure of this atom. So this is what an atom of carbon looks like. So what we want to do is we want to come to our lab sheet and we want to draw exactly what we just did. But instead of drawing circles, we're going to do shorthand here. So we're going to put a plus sign. And we know we have 6 protons because we have 6 red dots. We're going to take and put a 0 because we know that's our neutrons, or neutral. We have 6 of them. And we're going to put our electrons here. So we're going to put negative, and we have 6 electrons. So how did I know to do this? I looked at my example up here. Okay? So now using my periodic table and using my atom, we're going to answer the questions. Let me move my electrons out of the way. What is the atomic number? Well, if I come to my periodic table, the atomic number is the one that is on top, so it's 6. It's also the number of protons and electrons. What is the mass? The mass is the number at the bottom, which is 12. What is the symbol for carbon? It's C. Okay. Then it wants to know what is the electron configuration. Okay. That means how many of these outer shells that we have. But to simplify this for you guys, we're just going to say that it has 6 electrons. Just to keep it simple. Now, what is the net charge of this atom? Well, because this is just an atom of carbon, then it would be neutral. It is not charged, and it matches what should be on the periodic table. So this is how we build an atom. Now, what we want to do is we want to compare atoms to isotopes and compare them to ions. So you're going to build an atom of carbon. You're going to build an atom of oxygen, an atom of sodium on page 9, an atom of chlorine, and an atom of nitrogen. When you get to page 11, you'll see we've changed what we're actually going to be modeling. This time we're going to model isotopes. Remember, we're comparing and contrasting them. So if we learned in our last lesson, isotopes have a different number of neutrons. So I'm going to clear my board here. Let me put this down. Put my protons and my neutrons back where they go. And once again, you're going to use your same paper. You can use the same chips. Make sure you stick to the same key. And since we're talking about carbon, I'm going to continue to use carbon. So I'm going to be part 2, number 2. So this is on page 11. So this time we're modeling an isotope. So according to the instructions, it says use the information on the periodic table to model a normal carbon atom called carbon-12. So change the model to an isotope, meaning carbon-14. In other words, we just learned that a normal atom of carbon has 6 protons and 6 neutrons. That's what we just had. We also learned that it had 6 electrons. This is what we just made. Now the instructions want to turn this to an isotope of carbon-14. So we need to figure out, well, what's the difference here? We went from 12 to 14. That means that the mass increased by how much? Well, 14 minus 12 is 2. So this means that we have added 2 more neutrons than we're supposed to have. So we're going to add 2 more black chips to the center of our atom now. You notice if you were to go back into the video or you pause and you take a look at this, you can see now instead of having 6, we have 1, 2, 3, 4, 5, 6, 7, 8. We have an isotope now. The number of neutrons has changed as well as the mass. So we're going to come back over here and we're going to do the same thing. We're going to figure out how many protons, which even though it's an isotope, the number of protons never changes. So it's going to be 6. This time though, we just counted that it now has 8 neutrons because we went from stable 12 to 14. But our electrons didn't change either. 1, 2, 3, 4, 5, 6. So if we go over here and we look at the information, the atomic number of carbon didn't change. It's still 6. This time the mass changed. How do I know this? Well, it tells me up here, but to find the mass, I can add these 2 numbers together. What's 8 plus 6? 14. We're still dealing with carbon, so it's still C. What is the net charge of this isotope? Okay, well, it says use a plus sign for each proton and for each neutron or negative sign for each electron. We've gained neutrons, so they have no charge. So what would our net charge be? It would be anything still. So isotopes we see with carbon, we went from a stable atom of carbon to now we have one that has more mass. We have an isotope of carbon. So we're going to go to the last model. We're going to flip to page 13. Okay? Now, for all of the rest of these pages, you're going to do an isotope until you get to part 3. So I'm going to change this on my board. And we're going to go to part 3. Now, because we've been dealing with carbon, we are actually going to switch it up a little bit here. We're actually going to do sodium. So we're still going to go to part 2, or excuse me, part 3, and we're going to do number 2, but on page 14. This time we're looking at ions. We haven't seen this word in a long time, since our chemistry lessons, okay? If we remember, ions have different numbers of electrons.